So let's actually set up this difference quotient idea. My u and my v are going to be two different functions. Let's say that u is standing for f of x. Let's say that v is standing for g of x. So if I want to calculate a small change in the value of f of x times g of x, well, I'm supposed to have some finite amount that I move my x coordinate. We call that delta x. Delta u is just the difference in the two different u coordinates. So here I have f of x plus delta x minus f of x. And likewise for v. Delta v is going to be g of the quantity x plus delta x. And then I subtract g of x. So if I'm going to calculate how much does the product change, well, then delta of the quantity u times v has to be u plus delta u, quantity times quantity v plus delta v. And then I subtract the original value of u times v. So what have I got left? I've got u times delta v plus v times delta u plus delta u times delta v, exactly like the picture showed. So my algebra is reinforcing what the picture told me to do. Now, I still need to divide by my delta x. So I've gone ahead and I've done that. And I've grouped here into three different fractions. My difference quotient should be delta of u times v divided by delta x. This is going to be the same as u times the difference quotient delta v on delta x plus v times the difference quotient delta u on delta x plus delta u times the difference quotient delta v on delta x. This is starting to look like three different derivatives. And you can see that the reason why I'm using more variables here is because I want to treat each of these separately. I wouldn't be able to get away with that if I was using the same letter y for all the different parts of this function. Now, taking a derivative requires us to calculate a limit. So here I have my differential operator, d on dx, applied to the product u times v. And I'm going to break down that limit into the three different pieces like before. And now, well, my difference quotients are all going to become derivatives that I know how to calculate, as long as I have formulas for my different functions. So in the limit, as delta x goes to 0, I've got u times delta v on delta x. Well, that looks a lot like the derivative of v, right? This would be my Leibniz notation dv on dx. Likewise, I'm adding to that quantity v times the difference quotient delta u on delta x, and in the limit as delta x goes to 0, well, that just looks like the definition for derivative of u, the letter u, the variable u. Finally, the last term I have here is delta u times delta v on delta x, and there I do need to break down a little bit more. By itself, delta v divided by delta x in the limit as delta x approaches 0, well, that's going to be the derivative again, dv on dx. But in the limit as delta x goes to 0, delta u is just going to go to 0. So that part of the equation will get wiped out as promised. So this calculation with the limits, even though I don't have the formulas for these functions, tells me that d on dx applied to the product of u times v should be u times the derivative of v plus v times the derivative of u. Here we are again.